Project.
I feel like we are going to mess up in the middle of the videos, though, so we need to kind of...
Yeah, but like at the start. Hi everyone, I'm Calvin.
And I'm Marco.
And this is Walker Assist. Walker Assist is an augmented walker to help users around the home in placing items in different locations, because obviously when using a walker you'll be a little limited in movement. Basic functionality, it allows users to place items on here, i.e. dog bowl or something like that, lower the platform down and dispense it in different areas of the room. Now I'll have Marco go ahead and show you. Main inspirations for this though were what we directly saw with our own grandparents and family members, how they struggled around their own homes, and we wanted to be able to help them with that.
Okay, so yeah, we can get into like the main functions of the walker and go over like some of the main sensors that we use for the project. So right now we're running our code. You can see we have our breadboard on the side with our ESP32, and we have two separate motors here that are driving these sweepers, which help do the dispensing and collecting that Calvin mentioned. So you could, sweep an item off or sweep something onto the platform. And then on the back here, we have a shaft coupler that's inside of this kind of housing here. And we have an encoder. You can see the wires coming out the back. So that's measuring the rotations of the shaft, which directly correspond to the linear distance traveled by the platform here. And then for our digital sensor, we have two push buttons, which can either drive the motor up or down. And then we also have a potentiometer, which is our analog input, which reads the potentiometer value, and then that maps to basically the rotation of these two sweepers. So I think that covers all of our sensors. We have like motor drivers and stepper drivers attached. So I'll go over just the function now. So we start in this kind of like idling state where the walker is up. So this is where you can set something onto the platform. And then if we push the down button, we see that the platform will lower and the encoder will read the value until it reaches the floor. And so you see the pulley lowered the platform. Now that we're in a lowering state, we have two options. So we will choose to move the sweepers, which we can rotate the potentiometer here on the side. And you'll see that these will sweep out. And if we want to bring them back in, we rotate it the other way. So we can either dispense or collect. And then if we push the up button here on the breadboard, we see the platform will go up again. And the two sweepers will reset at the 0 position. And now we're back in this initial state 0. So yeah, that covers the main functions of the walker.
And so a little subsystem we want to highlight is this worm gear implementation. So basically what's happening here, this motor shaft will spinning this worm, which interfaces with this worm gear and can then spin the main shaft. This is something we're especially proud of because aligning this is quite difficult. And we have a lot of different ways that we do that throughout the system. Additionally, we want to show a little non-standard function, which in this case would be lowering the platform and then deciding against lowering something down and picking it up directly, which is an option in this case, if you want to show that, Marco.
Yeah, so once again, if we push the down button, now that we're in like the homing or the idling state, you can drive the platform down. And then instead of moving the sweepers like I did previously, I can just push the up button now from this state, and it should just drive straight back up.
Allows you to, if you change your mind, want to pick the thing up again or do this or that, you have the option to go change that.
Yeah, and a couple other things I wanted to add before we end the video, just some things that we learned throughout the process. It's hard to tell from just looking at our final product, but it was very difficult to get, like Calvin was saying, good alignment, like augmenting on an existing product, because there are a lot of non-parallel lines on the walker, and this also is a foldable walker, so it's not very precise in terms of when it unfolds, and there's weird angles that are, at small angles, but not perfectly straight or parallel or perpendicular. Also, we really wanted to prioritize keeping the function of the walker, which is to be able to walk with it, so we were very conscious of how much space we were utilizing and also how much weight we were adding, which is why a lot of our components are pretty lightweight. So we have these like pipe clamps. Sorry, I pushed the button on accident. We have some pipe clamps that are not very robust necessarily, but yeah. Do you have any other things to add?
Nope. Thank you for your time, and go Walker Assist.
I'm not sure what just happened. I literally I did not push